Okay, so part 2. Here we go. With part D here, we got to deal with the transformation. All right, so the plus 10 means that we are going to be shifting it to the left 10 units. And the minus 3, that means we're going to be shifting it down 3 units. So our asymptotes, it's going to be shifting to the left 10. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we're going to have this is our vertical asymptote, and then it's shifting down 3. So it looks like that. And then your graph, kind of ran out of room here, but you're going to have this piece here, and then, oh, I apologize. I messed up. Hold on. Let's see. So you're going to have this piece here, like so. All right. And then you're going to have this piece down here. All right. So that's going to be your graph. I apologize, this is not the best picture, but there it is. And so my vertical asymptote is going to be at x equals -10. Horizontal asymptote is going to be at y equals -3. All right. And then as far as the domain and range, domain, all right, the only thing that x cannot equal is -10. Look at that denominator. So -∞ to -10, union -10 to +infinity. The range, all right, the only y value we cannot have is that -3. So it's going to go from -∞ to -3, union -3 to +infinity. All right, as far as the x-intercepts go, this time we're actually going to have one. You can kind of see that we're going to have one. X-intercept is when y equals 0, so you've got 0 over 1 over x plus 10 minus 3. Add the 3, you're going to have 3 equals 1 over x plus 10. Cross multiply, you're going to get 3x plus 30 equals 1. Subtract the 30, you get -29. Divide by 3, you're going to get -29/3. Not the nicest number, but that's going to be your x-intercept. So -29/3 comma 0. Y-intercept is when x equals 0. So if you plug in 0, you get 1/10 minus 3. 1/10 minus 3, you can do that on your calculator. You're going to end up with -29 over 10. So you're going to have 0, -29 over 10. All right, so that's going to be your x-intercept, your y-intercept. Let's see. We've got increasing and decreasing. So increasing, as you go from left to right, that's decreasing, and that's decreasing, so it never increases. Decreasing, it's going to go from -∞ to -10. And then it's also going to go from -10 to +infinity. All right, so that's decreasing. And then end behavior. All right, as we go to +infinity, the y values are getting closer and closer to that -3. So as x goes to infinity, f of x approaches -3. And then same thing going to the left. As x goes to -infinity, as we go to the left, the y values are also getting closer to -3. So as x approaches -infinity, f of x approaches -3. All right, so after this point, you guys are good to go. You should be able to do day 10 homework without any problems. These notes do continue on to Monday, which is a late start. So I'm just going to continue to do a little bit more of these notes. But again, after this point, you are good to go. You should be able to do the day 10 homework without any troubles. All right. We're going to talk a little bit about horizontal asymptotes. I know that you've done this before. To figure out where the horizontal asymptote is from an actual equation, if the degree of the numerator equals the degree of the denominator, then it's going to be the ratio of the lead coefficients. Y equals whatever that happens to be. And I'll show you how that works in a moment. If the degree of the denominator is greater than the degree of the numerator, then the horizontal asymptote will just be y equals 0. And then this one is always the fun one. If the degree of the numerator, so the exponent on top, is bigger than the exponent on the bottom, then you got to divide. All right, we've been doing synthetic division. We're going to actually be doing long division now, because that's kind of the best way to do it. And so the asymptotes, in this particular case, will probably not be horizontal lines, but instead will be some kind of linear, which is called an oblique, or some kind of quadratic. So you might end up having some kind of crazy graph that has, instead of a horizontal asymptote, it has like a linear or oblique asymptote, and it might look, you know, something like this, all right, where it's not a horizontal line. It's going to be either like a linear, like a line, or it might be like, you might even have an asymptote that's more of like a parabola type shape, parabolic. So that's something to keep in mind. We're going to do a little bit with the long division because that's going to be necessary if you have a degree of numerator bigger than the degree of the denominator. All right, so if you have something like this, and I know you've seen this before, we're dividing this x cubed polynomial by this x squared polynomial. All right, so you look at the x squared and you look at the x cubed, and you have to think, okay, what can I multiply x squared by to get x cubed? X squared times x to the first will get you x cubed. Since it's x squared times x to the first can't go here. It has to go above the same x that has the same coefficient. So since it's x to the first and this is x to the first, we're going to put it here. If it was like an x squared, you'd have to put it above the negative 2x squared. X times x squared is x cubed. X times 4x is 4x squared. X times negative 1 is negative x. Now the biggest difference between this and synthetic is we're subtracting. So when you subtract, x cubed minus x cubed is gone. Negative 2x squared minus 4x squared. If you want to think of this as like add the opposite, that might even be easier. So you could do, you know, add the opposite. Negative 2x squared and negative 4x squared is negative 6x squared. 3x and 1x is 4x. Okay. Once you do that, then you got to bring down the next term, which is 6. And then we start again. X squared times what is negative 6x squared? X squared times negative 6 will give you negative 6x squared. So you distribute negative 6 times x squared is negative 6x squared. Negative 6 times 4x is 24x. And negative 6 times 1 is positive 6. When you subtract, you will not get a remainder of 0, and that's okay. So negative 6 squared minus negative 6x squared, that's gone. I'm going to do add the opposite. I just like to add better. So I'm going to make all of these their opposites, so it's a lot easier. These cancel. 4x and negative 24x is negative 20x. And then these cancel, giving you 0. All right, so you have negative 20x. And so what's going to happen is you're going to have a remainder of negative 20x, or negative 20x over this thing, x squared plus 4x minus 1. All right. And usually you put the remainder over whatever you're dividing by. This thing, though, isn't going to be really important because if you were to graph this, as x approaches infinity, this thing is going to approach 0, which means that it's really not super important. It's not going to have a lot of bearing on what the actual horizontal asymptote or oblique or quadratic might be. So a lot of times what you're going to do is you're going to divide, and then this will be your horizontal asymptote or your oblique. And you'll kind of ignore the remainder, which is kind of nice. So that's just kind of a heads up. You'll see what I'm talking about when we get to these problems on the next page. All right, number 1 is kind of a doozy, so we're going to skip number 1 for right now. We'll do that together on Monday. Let's look at number 2. Okay, with number 2, all we're doing with these is finding the asymptotes. All right, so dealing with the horizontal asymptotes, you're going to look at the degree. We've got a degree of 2 and a degree of 2. All right, if the degrees are equal, then you're going to just do the ratio of the lead coefficients. So 8 over 4 is 2. So my horizontal asymptote will be y equals 2. All right. As far as the vertical asymptotes go, look at the denominator. All right. What can it equal? 4x squared minus 1 can't equal 0. So if you were to solve this thing, you'd get x squared equals 1/4. So it wouldn't be able to equal plus or minus the square root of 1/4 or plus or minus 1/2, right? So that would be your vertical asymptote. X equals 1/2 and x equals negative 1/2. All right. For the next one, the degree of the top is smaller than the degree of the bottom. So if you look at that, the degree of the denominator is smaller. Wait, is the degree of the denominator smaller? Sorry, the degree of the denominator is greater. The degree of the denominator is greater than the numerator, so it's going to be y equals 0. Okay, so the horizontal asymptote is going to be y equals 0. As far as the vertical asymptote goes, all right, you look at the denominator. X cubed minus 27 can't equal 0. X cubed can't equal 27. So x cannot equal the cube root of 27, which is 3. Okay, so my vertical asymptote is going to be x equals 3. Okay, the next one is where we're going to get into. So in the next one, you'll notice that the degree of the numerator is greater than the degree in the denominator. And when the degree of the numerator, the degree of the numerator is greater, all right, that's when you're going to have to do the division. So let's do our division. All right, so we're going to do this 3x squared minus 3x to the fourth minus x squared. And remember, you got to have placeholders. So we don't have an x cubed, so we need a 0. We've got minus x squared, we don't have an x, and we don't have a number. And then we have x cubed minus x squared plus 0x plus 1. Don't forget your placeholders. All right, and then we're going to divide this thing out. So we have to turn it into a 3x to the fourth. X cubed times what will give you 3x to the fourth? That would be 3x. That has to go above the x. 3x times this would be 3x to the fourth. All right, minus 3x cubed. 3x times 0x is 0x squared. And then 3x times 1 is 3x. Okay, and we're going to be subtracting them, or add the opposite, which is what I like to do. And so when you add them together, these cancel. You're left with 3x cubed. This is a negative x squared. All right, because you got the negative x squared. And then you've got a negative 3x. Bring down the next term, you've got 0. All right, and so then we need to figure out x cubed times what will give you 3x cubed. X cubed times 3 is 3x cubed. So 3 times x cubed is 3x cubed. 3 times x squared is negative 3x squared. 3 times 0x is 0x. 3 times 1 is 3. And then you subtract, or add the opposite. These cancel. Negative x squared and 3x squared is 2x squared. Negative 3x and 0x is negative 3x. And then you got a minus 3. All right, now this is your remainder, but again, remember, as x approaches infinity, this thing is going to approach 0, so it's not really important. All right, so you don't really need this part. This is the part that's important. So instead of a horizontal asymptote, since this is linear, that's going to be called an oblique asymptote. And the oblique asymptote is going to be following this line, y equals 3x plus 3. Okay. And then as far as the vertical asymptote goes, all right, the vertical asymptote, we know that x cubed minus x squared plus 1 can't equal 0. Since it's not a quadratic, we can't do the quadratic formula. It doesn't factor nicely. So this one you can find on your calculator. Just graph this piece and see where it crosses the x-axis. And where it crosses the x-axis is going to be, if I round it, negative 0.755. All All right, so that one's a little tricky. You have to do it on your calculator. All right, that's it. I've run out of time.